In problem number 32, we have this function f of x is x cubed plus 1. And we're told that it is 1 to 1, and that therefore the inverse function y equals f inverse of x exists. And which of the following is an equation for y equals f inverse of x? So let's just talk for a second about one-to-one functions, inverse functions, and then how we go about calculating or finding inverse functions. So let's talk about a function. A function has the property that for every x value, there is only one y value that's associated with it. And we say that it passes the vertical line test. So that for any vertical line that we draw through the graph, it passes through the graph in only one point. So if it doesn't do that, then it's not a function, and if it does do that, then it is a function. For every x value, there's one and only one y value. Now the next graph is a graph that is one-to-one, and it not only passes the vertical line test, it also passes the horizontal line test. In the example above, if I drew, or I could draw a horizontal line that passes through that curve in 3 different places, and so that would not be a one-to-one function. Not only does it need to have only one y for every x, it also should have only one x for every y. And so the function below does have those properties, both of those properties, such that we can, for any vertical line we draw, we will only pass through the graph in one place, and for any horizontal line we draw, we will only pass through the graph in one place. So that's a one-to-one function. And only one-to-one functions have inverses, and let's talk about how we go about finding the inverse function to a function. We start with the function itself. If it's written as f of x equals x cubed plus 1, we write it as y equals x cubed plus 1, and then we swap the x's and the y's. And finally, we're going to solve for y. So the first thing we do is subtract 1 from both sides. Next thing that we'll do is we will cube root both sides, find the cube root of both sides. And so the inverse function, which we'd write as f inverse, f negative 1 of x, is y, is cube root of x minus 1, which is b. Be careful it's not c, because the 1 is under the radical there. Okay, so that's it for problem 32.